we last looked at hydraulic pressure. This is going to be part 2 of 13.1, number 2. And this is going to be taking a look at water pressure and the calculation of water pressure. So imagine that you have a giant water tower or a water container. We talked about water pressure and voltage, but let's say that it's filled up to this height right here. And you can experience this when you dive into a pool. What happens to your ears when you dive down to the bottom? Your ears start to hurt. Why? Because there's more water pushing down on top of you. So in terms of the water pressure right here at the surface, you're going to have a lower pressure, and when you're down here, you're going to have a higher pressure. So we know that the height of the water column is going to be one of the factors in determining the water pressure. So let's start off with the formula for pressure. Pressure is equal to force over area. So this force that is going to be generated for this is going to be the weight of the water column as it's going to be pushing down on top of you to create that pressure. So this F right here, this is going to be the weight. So it's going to be the weight of the water column. So we're going to do some substitutions to come up to our ultimate formula for this. So we're going to do some substitution in here, and pressure is going to be equal to, for force, we're going to substitute in mass times gravity. So it's going to be the mass of the water, and of course gravity, which is pulling down, that's going to be affecting the pressure. And all of this is going to be over area. So we're going to go back to chemistry and use a common formula that you guys might remember, and that's going to be density. I'm going to write this over here. Density is equal to mass over volume. So in physics, chemistry is not a capital D. It's actually going to be the Greek symbol rho. It looks like a P with a tail. This is a Greek letter rho. Oh, we're not over. So density is equal to mass over volume. But I want to solve for a mass, so I'm going to multiply both sides by volume. Multiply both sides by volume. So my mass, those will cancel. Mass is going to be equal to the volume times the density. We're going to plug this in to this formula right here. So pressure is going to be equal to the volume times the density times gravity all over area. So now, going back to this tank is in the shape of a cylinder. And what is the volume of a cylinder? So the volume of a cylinder, if you remember from geometry, is equal to the area of the base times the height. So it's the area of the base, which is going to be a circle, times the height. So we're going to plug this now into this formula. So my pressure is going to be equal to, substituting in for volume, we're going to get the area times the height for the volume times the density times the gravity all over the area. I think you can see how this is going to simplify now. So what is pressure really based upon? Let's put this in the final form which you're going to be seeing it. It's going to be equal to rho g h. The pressure that you experience at the bottom of a pool is dependent upon the density of the material. The denser that the material is, the more pressure that there'll be. Imagine if this were honey, for example. Honey would be pushing down on top of you more than plain water because it's denser. So your pressure is based upon density, gravity, and of course, the height. So in terms of hydroelectric power, if you have a dam and here you have your turbines, so we're just going to have an opening right here. Here's the, let's say the water level's right here, okay? And here's where the water flows through, and you can see it pouring out through the chutes, and inside you'll have your magnets that are spinning with their wires, and that will generate electricity. So as the water flows through, what's going to create more electricity is higher water pressure. So you have all this height of water pushing down. So if you have a higher water table or higher water column, you're going to have more pressure pushing down. Okay, so this will be a higher pressure. And then if you have it here, it's going to be a lower pressure. Because here, you're going to have more water pressure pushing down. Here, you'll have less height pushing down. So here, each of your heights, small height will equal smaller pressure, larger height will equal a larger pressure. That's it.